And the somatic, we further divide that as cranial nerves, that's the craniospinal nerves. So we have nerves that come out directly from the brain. So though these nerves come directly from the brain, so we still tag them or we still label them under the peripheral nervous system because they have exited the cranial cavity and they are going to innervate the peripheral structures. So we have the cranial nerves, 12 pairs of cranial nerves, and we have got the spinal nerves, 31 pairs of spinal nerves. Okay, so we'll talk about the procedures on these nerves tomorrow, especially by way of injections. Today we'll focus more on the central nervous system. The procedures that have been done on the brain, the cranial cavity, the cranial bones, and all that. Okay, before that, so we know that this brain is lodged within the cranial cavity. So, what are the cranial bones? How many are there? So, name the cranial bones. How many are there? Name them. Okay, remember, I gave you a hint.
Frontal, parietal, occipital, temporal, ethmoid, sphenoid.
Very good. F part S, isn't it? So you have the frontal, which is a singular bone, and then we have got the parietal bones. So these are paired bones. Parietal, occipital, temporal. So temporal and parietal are paired. So though there are only 6 bones, these are paired. So giving the count to 8. Frontal, parietal, occipital, temporal, ethmoid, sphenoid. Now the ethmoid and sphenoid, they form the base of the cranial cavity. Okay, they form the base, or in other words we say as the floor of the cranial cavity. Okay, so we have the roof, isn't it? So we also have the roof of the cranial cavity, so we call that as a cranial vault or the cranial roof. So this skull bone, no, we say it as calvarium. Now this calvarium, which is going to enclose a space, and this space is being occupied by the brain. So we call that as a cranial cavity. So we have the roof, we have the floor, as well as the side walls. Now, if a neurosurgeon wants to do any surgery, okay, if he wants to perform any surgery, so he will have to go into this brain, isn't it? So how the doctor can go into the brain? How the doctor can go into the brain? How he can go into the brain, man? So he'll have to make either drilling. If you see, our government is taking this methane, ethane, everything they take. So what are they doing? They are drilling all the agricultural fields, isn't it? The Kaveri belt, the Kaveri delta in Tamil Nadu, and if you see in Andhra, they are calling their Tungabhadra, that those Krishna river basins, Godavari, they are all tapping all resources there, isn't it? So they can drill out. So drilling out the procedures can be done. That's one thing. Okay. Now, secondly, the doctor can do a craniotomy or a craniectomy. The physician can perform craniotomy or a craniectomy. So you need to understand. So drill out where he's going to actually pass a device called as a trephine, or manually with a handheld device, he can twist it. And you know how to make drill. It's like you want to drill something on your walls for nailing purposes. We have this machine, no, electrical machine. So when we talk about this drilling, you need to know whether it is being done manually or is it being done electrically with any powered device. So if we do an electrical or a powered drilling, we call it as a burr hole. Burrhole. Okay, burr hole. Burr in the sense electrical drilling it is. So the surgeon can also perform with a manually handheld twist drill. So the procedure can also be called as trephination. Trephination or a twist drilling all mean the same. But if this trephination is being done electrically, we call it as a burr hole. Next, you can do a craniotomy where the physician is going to open up. He is going to make a surgical cut and he can do whatever procedures he wants. And then the next thing would be a craniectomy. Say, for example, the patient has met with an accident where there is a traumatic fracture of the skull. So the patient can have a comminuted fracture or an open fracture or a compound fracture or a depressed fracture. What if a person has hit someone with a hammer? So there can be a depressed fracture. So there can be several bony fragments, isn't it? So that can give rise to a compound fracture, or in a very complicated accident, you can also see this brain getting exposed. Now those are compound fractures of the skull. So at that time, what a doctor does, he is going to excise the broken bone fragments. Now that would amount to a craniectomy. Okay, craniectomy. So you need to understand what exactly is the approach. Is it a via drilling, or is it via craniotomy, or is it via craniectomy? Okay. Now let's talk about this brain. So the human brain weighs around 1,300 grams. So it's even less than 1.5 kg. And we don't feel the weight of it, isn't it? Because we have those bones which are sinuses. Okay, now if you talk about the human brain, so we have a very large portion called as cerebrum, which is being divided into lobes: frontal, parietal, occipital, temporal. Each lobe has their own functions. So we have cerebrum, and then we have cerebellum, which is called as a little brain. So we have cerebellum, which is called as a little brain stem. Now medulla continuous downwards to the spinal cord. Now in between, we have something called as diencephalon. Okay, we have something called as diencephalon, which consists of this infrabrain. So we have the thalamus, the subthalamus, the epithalamus, the hypothalamus. So the word thalamus means bed. Now these are subcortical structures. So they are not seen just by an observation. So you'll have to dissect into the brain and look out for these structures. Now these structures play a principal role in relaying the information from the lower centers, and they transmit them to the higher centers like the cerebral cortex. So the brain has convolutions, and it has convolutions, the ups and downs. We call them as sulci and gyri. So the outer exposed surface is the cerebral cortex, isn't it? And then we have this white structure. So we call this as, so we have this, we have this nuclei of each cell. So when you talk about a single cell, the structural function unit of the nervous system, we say it as a neuron. Now this neuron has a cell body, isn't it? So what is happening with this nervous system is a kind of connections are being established with all the neighboring nerves. So any information which is being received by these nerves through action potential, through neurotransmission. Now neurotransmission takes place through certain substances called as neurotransmitters. So when a nerve is going to communicate with another nerve, now these chemical substances, including this calcium ions, are being liberated, thereby causing an action potential. So current flows in our brain, just like as in our heart. So this cell body, it is going to receive the information through these dendrites, which are the branch structures, and then the cell body, which contains the nucleus, is going to process that information, and then that information is being relayed. It is being transmitted to a neighboring neuron through these axonal fibers. And we have these Schwann cells there. Now, tumors can also arise from these Schwann cells. We call it as schwannoma. And in between these neurons, we have certain supporting cells called as glial cells, or we say this, call them as astrocytes. These are star-shaped cells. So tumors can also arise from them. We call them as glioma, or we say astrocytoma. Okay, so these tumors are also common within the brainy substance. So the outer exposed surface we say as a gray matter, and then the subcortical structures we call them as a white matter, because these white matter are nothing but this myelin sheath of these axonal fibers. So in conditions like multiple sclerosis, this myelin sheath is getting lost. The patient can start developing tremors, difficulty in speaking, slurred speech. So all this can take place in multiple sclerosis. Say main conditions like Alzheimer's disease or Parkinsonism. Now, patients can also develop tremors, dyskinesia, memory disturbances. All this takes place because of